I'd like to thank Semi for inviting me here today. I also presented back in July at SEMICON West, basically the same presentation. Macronix is actually a Taiwanese company. We're headquartered in Hsinchu. All right. Before I kind of go into what I'm talking about, now we're getting down to the component level. Today, I think there's a lot of new technology that is driving autonomous driving, which is great. But behind a lot of that, you have to think about is, how do these things boot up? A lot of them have to boot up from non-volatile memory, which is flash. So in a system, if you look at it, there's really three things that are really the brains or system startup. It's really the processor, the MCU, the DRAM, and flash. So flash has been around for more than 30 years, right? So I'll kind of give you an overview of flash, kind of give you an idea of where it's been in automotive and where it's kind of going, right? All right, so earlier we looked at a lot of markets that are $1 trillion, right? $5 trillion, $12 trillion, big, massive markets, right? Flash itself, it looks like it's going to grow, according to some analysts, maybe $100 billion. That's part of the overall electronic industry. The flash market's about 50% CAGR. It's growing massively right now. A lot of the industry right now, if you look at it, is on allocation. And really the key drivers, if you look at flash, and I'm not going to go into it, is really mobile and storage. Okay, so you're talking about cloud computing. That's driving a lot of the massive SSD market, which that's not a market we're in. But if you look down at really the NOR flash, okay, it continues to expand, and I think a couple of years ago it was hovering maybe about $1.8 to $2 billion, but I think with the advent of markets like automotive and IoT, we're looking at NOR market actually growing to about $4 billion. Okay, so years ago everybody thought NOR would go away. But in fact, right now the key drivers are automotive, data centers, and IoT. Okay, so if you kind of dig a little bit deeper and look at SoC NAND and SPI NAND, okay, that's kind of part of the market we're also looking into. It's kind of declining consumer and automotive. It's been taken over by eMMC and managed NAND. Right? So if you look at just the automotive flash market itself, taking out eMMC and really the higher density market space, you notice the parallel NOR flash is declining. The serial NOR flash is definitely taking up a majority of that space, and NAND is kind of stable. All right, and before I kind of get in there, I kind of want to talk about why NOR has been around. Okay, it's kind of transformed from parallel NOR to serial NOR, and it's really because it's the high quality. Automotive has to lead with quality. Okay, you got ACQ 100, ISO, and then of course functional safety. But the other part of it is really the extreme temperature conditions. Okay, like 125 degrees or even higher. And it's not even under hood anymore. You're looking at some of this autonomous driving market that requires the flash memory and even the DRAM now, okay, having to withstand 105, 125 degrees, right? So I'll give you an idea. The NVIDIA system now for autonomous driving, okay, it's about 320 ter operations per second, but it's putting out 500 watts. So any devices that's sitting next to those devices, okay, like our memory, has to be able to withstand the very high temperature. Okay. So some of the other barriers for entry, if you look at it, is long design cycles. You got to have longevity of supply, high performance solutions, and then of course, it's a lot of high upfront investment in terms of cost. Okay. So what does that mean? For some of you who are building these modules for LiDAR, radar, etc., okay, you got to be able to find the right partners, okay, that can support all this, okay. And Macronix, of course, we started this industry in automotive 2004 or even beyond that. Okay, so it's about 14 years. We're getting to the point right now where we're being recognized in the automotive industry. So really, the upfront investment is very high. Okay? And then the complexity. Okay, so which means, and I kind of put in the lines of code. So if you look at it, the Hubble telescope, 2 million lines of code, kind of go all the way down to even a jet fighter, 25 million lines of code. Okay, a luxury car now, 100 million lines of code. All right, and that doesn't even include autonomous driving, artificial intelligence. Okay, I mean those numbers are going massive. So what does that mean? It means a lot of memory. Okay, a lot of memory that's going to be used in a car. So somebody asked me, like, why do cars have to be complex in terms of code? And airplanes are, they don't have as many lines of code. And really, the reality is, you got a lot more cars on the road. There's a lot of people jumping out in front of you. There's a lot of obstructions. But in the air, it's really one plane, every, tens of miles, hundreds of miles away, right? There's not a lot of objects that's going to come in and hit an airplane. But in a car, right, you have to be able to avoid those things. All right, so these are the macro trends. I'm not going to go through it because a lot of my predecessors have actually talked about it. But of course, a lot of these are actually driving, flash memory usage. All right. So I got a little video. Hopefully, it wakes you up a little bit. All right, so that's a much better introduction than I can ever do about my company. So there's a few things that's in there. Hopefully you're able to kind of see it. It's really quality, right? Which that's the number one thing about our company. Number two is really the performance aspect. Okay, so especially nowadays, you got a lot of sensors that have to come on instantly. All right, you have to be able to have the performance to do that. The other thing is longevity supply, having our own fab, etc. So those are really the key components, I believe, moving forward, especially finding a partner with us. All right? So here I kind of put up a little bit of the auto design cycle. I'm sure most of you know this. It's very long. Like the BMW F30 model. Okay, 95% of the electrical architecture was actually designed 10 years ago. So everything, all the cars that are coming out now, been designed many, many years ago. Okay, the G20, okay, it's going to be launched in 2019. A lot of this been architected at least 2 years ago. Okay, so now looking back at Flash, I'm just kind of focused on the Flash aspect now, NOR Flash. When I first started out in 1996, 1992, right? It's been a long time. A lot of the flash that were used were in infotainment systems, okay? Some of them was used for under-hood applications like ECU. I remember I think back then people were buying those EEPROMs to kind of soup up their cars, right? You can buy them, through those car magazines, right? And that's how they started out with EEPROMs. And then flash came in, and they're used in radios, telematics, and navigation systems, right? So, back in the early 2000, the flash market, especially in automotive, kind of peaked. Okay, but really, the convergence and center stack, kind of helped along with higher memory usage. Because back then, a lot of these memory pretty small, 4 megabit, 16 megabit. Okay, but now as you kind of move along, okay, especially with clusters, you're starting to see much higher densities, like 120 megabit to 56 megabit. But honestly, with ADAS, we're looking at systems that are going from, with electrification, ADAS, it's really spurring much higher density. Okay, so I'll give you an example. I can't go into who our partner is, but we work with pretty much all the tier ones out there. But in one ADAS platform, you've got 60 megabit to work on the Ethernet bus. You got GPU that has to boot up with a 60 megabit. But really, the ADAS processor and the sensor fusion processor, you're looking at 1 gigabit. Right? Five years ago, nobody talked about a 1 gigabit NOR. Right? It was all NAND. But the reason why NOR is really because it's a higher temperature, higher reliability that's being used. Right? So now you're looking at much higher density devices that are going into autonomous driving. That's really why it's driving the growth of NOR flash in automotive. I think most of you have actually seen this. I'm not going to go through it, but kind of give you an idea. Now, if you look at, in a car, as you move up to level 4 and 5, there's a lot more sensors that's going in there. And each sensor, if you look at it, requires definitely a lot more flash. Right? The more sensors there are, there's a lot more flash. And if you look at, I think earlier we talked about radar and LiDAR. Okay, they're becoming smarter. So what does that mean? The sensors have to be smarter. That means they have to make decisions on the edge. Okay, and as they make decisions on the edge, they need more memory. Okay. All right. Same thing with cameras. Okay, you got forward cameras, rear cameras, but really, you're looking at an average. Okay, of about 6 cameras in a car by 2022. Of course, the much higher end cars will have a lot more cameras. You're talking about in-cabin cameras that are monitoring the drivers. You have the cameras outside. You have the forward cameras. All right. Same thing with LiDAR. I think the very same thing. You got to be able to. I think some of these technologies on LiDAR, to me, it's very exciting. Especially, I learned so much today about LiDAR. Being able to shrink it down and be able to put it in front of the cars like that. And so if you're talking about 4 to 5 different LiDAR systems, or systems in a car. Same thing with radar. Now, if you look at it, I mean, radar before used to have embedded flash, which means the flash is actually embedded in the radar itself. But now, because of you've got smart radar, you've got now cognitive radar. Again, you have to have a lot more external flash. Right? And then the other thing I think everyone has to realize is as these technologies shrink, meaning they're going to lower and lower geometry, you can't embed flash anymore. Okay? You have to use external flash. Right? I think below 50 nanometer, I think some technologies are trying to go into other technologies like RRAM. But even that is unproven, and it's still very early stages. Okay, but really, flash has been proven. It's been there for 30 plus years. Same with connected cars. You've got telematic systems. You got a lot of systems out there that require a lot of flash. So in summary, I'll kind of summarize. The flash market continues to grow about 18% CAGR, which is very impressive. The NOR flash will double to about $4 billion by 2022. A lot of the growth drivers, engine electrifications, ADAS, okay? Some of the sensors in there, especially with cameras, 6 cameras per car, and really AI right now that's driving the autonomous driving level 4 and 5 needs large memories of flash, 1 gigabit, 2 gigabit flash, okay, up to 125 degrees. Okay? And then the other thing is that we don't really touch about. So if you look at cars like Tesla, they're able to do what? Update while the car is sitting in your garage. Okay, so that's over-the-air update. Okay? So that's something that's also kind of spur the necessity for flash. Okay? And then the other thing we kind of touched on earlier is security. Even the flash has to be secure. So that's another technology that we're working on with a lot of partners is on security. Okay? You have to prevent anti-tampering and anti-hacking. Right? So in summary, Macronix, we are one of the leaders in automotive NOR. We believe in about 2-3 years we should be #1. We have the best in class performance at 500 megabytes per second, best in quality. So if you look at it, we even have grade 0 products. And right now we're looking at less than 1 DPPM in terms of our quality for automotive. That's pretty impressive given my history in this industry. Right? We own our own fab, and we do have the best in-class technology out there. Right? I think that's it. I've got a few other slides, but they're really just background. So, thank you.
Oh, sorry. Any question here?
Sure. Just a quick question. You mentioned NOR flash, and it's going to double in terms of market size and all that. But I think there are also challenges in increasing the density of NOR flash in general. So obviously increasing the capacity versus the density is not really increasing that much. There's a conflict. So what do you see about that?
Yeah, I mean, for radar, I don't see radar needing that much memory. Right? I mean, right now, I think we are topping out about 2 gigabit, right, in NOR. So far, that's been enough for a lot of the technologies that we're in. And you're right. Years ago, I think the same issues that we faced was a lot of the technology was topping out about 256 megabit, 512. But if there's a requirement and there's a need, I gotta believe the technology will happen. Okay, and I don't know what that is. It could be 3D NOR. It could be any technology that spurs the growth of memory, the memory size. Right? Thank you.
Any other questions? No? Okay, I have one simple question. Very simple one. So when we talk about the cameras, right? So we know the camera for phone is much cheaper, compared to the camera for the automotive, right? Yeah. So because I have no idea about it, so the flash here is kind of the same to the flash we're using for a computer, or is it totally different? Then if that's different, then how about the cost difference?
Yeah. So well, I think anything in automotive, there's a big difference because of quality. I mean, I'll tell you, a lot of flash goes into a lot of things. Consumer electronics, right? TVs, set-top boxes, etc. Right? Yes, the same type of memory does go into cars, but the testing requirement there, now moving forward, we have to design for automotive, right? Be able to design to try to hit 1 ppm or less. Be able to design for very extreme temperatures, right? And then really, in terms of performance, we're trying to design to meet the demand of autonomous driving too, is really the performance. These systems have to come up in less than a second, right? Try to boot a system that requires 1 gigabit of memory, right? In a second. That's a challenge, right? Good question. Thank you.
Great. Let's thank the speaker. Excellent. Thank you.